Welcome everyone. Today we have our another new episode, and this episode is very very important because we will discuss about healthcare and deep learning process. We have our world famous speaker, Professor Enderly. Thank you. After a long time, you joined with us. We finished a summit without you. Definitely, we miss you. We have Professor David Smith. He already win a lot of our people hearts. Mr. Markley always support us. Mr. Marshalls as well as Mr. Adam. I want to share some good news because yesterday I shared that World Talent Economy Forum we will organize a debate in between human and artificial intelligence. Beside that, we want to arrange a debate, like professional debate, like today's speakers. They can join in Thursday night debate, and we can do debate on AI, on human resources. We will find out the topic and we will arrange the debating competitions. And already, International Islamic University, they are Oxford Ivy and Cambridge Ivy champions. All of the famous speakers, they already confirmed World Talent Economy Forums. They will attend in our debating activities. And most importantly, I believe that after IBM, we will organize another debate in between human and AI. And definitely from the human resources, we will arrange best debater from Asia Pacific. You have to understand, International Islamic University always they become champion this kind of championship. Another good news, I request all of you, you can observe our School of Talent Economy. According to our commitments, we are working with University of Cambridge, and we are creating employment in Africa, because when we develop our summit, that time we have commitment to the Rwanda people that we will create employment. Already we get 300 people job opportunities, and yes, we are providing training to the Rwanda people. Already they are joining from yesterday, and we are providing training from our speaker. Those who want to support our initiative as a trainer, we need a very good public speaker because they need to get a very good IELTS score. So all of you are native speakers, so your support will be very helpful for World Talent Economy Forum. So this is the things we are taking actions. We want to integrate it with AI and human resources for the debating competitions, as well as we are taking initiative for human resource developments, and we confirm that those who successfully achieve their score, they will get a very successful job from UK. So this is our talent economy. Always I try to commit it what I can, and I want to give special thanks to our speakers, those who continuously support World Talent Economy Forum. Professor Rob, what do you want to analyze about today's topic, especially healthcare, deep learning, artificial intelligence? Very interesting subject today. Professor Rob.
Sure. Deep learning, as opposed to machine learning, is a layered algorithmic approach to analyze data. It doesn't require the programming overhead machine learning has. On the other hand, it does require massive amounts of data in order to function. It basically trains itself. The areas that deep learning is being used in healthcare, here are a couple, then I'll let somebody else take over. It's being used for image analysis, so that if you have an X-ray or some other image that's created through a CT scan or a magnetic resonance, the deep learning computer can look at that particular image, and based on the massive amount of data that it's consumed, make a reasonable diagnosis as to what the underlying problem is. Another area that I think is more interesting is natural language processing. And one of the big problems, of course, we're experiencing right now in healthcare is a pretty large shortage of healthcare professionals. And people are left in rooms often with multiple patients, none of which are able to converse, often conscious, but on some type of a respirator to help them breathe. And the end result is that it would be nice if they could communicate with something, and something could communicate back with them. By placing a microphone in the respirator, they could talk to a computer, and that computer could at least converse with them about their illness, carry messages, whatever, in terms of keeping them or allowing them to have some type of peace of mind. It's also being used in retirement communities to help folks that don't have relatives or friends anymore because they've all died out, to have somebody to have something to talk to and converse with. And one of the other areas, of course, is if you're calling into a healthcare facility, right now you're often talking to a robot for a great deal of the time, and that robot can only do one thing, and that's put you on hold, and then pass you over to whoever you're trying to call. A deep learning machine could actually have a conversation with you, help diagnose the problem you have, and then, of course, if you've got a critical problem, automatically escalate that problem to a medical professional that is there, and they could address it so you're not having a massive, catastrophic problem while you're being held on the phone. But those are a couple of things that where deep learning is being applied into healthcare.
Thank you, sir. Professor David Smith.
Well, Rob's done an excellent job of helping frame the question here with how you really look at the deep learning in healthcare, and how AI and natural language program and machine learning are really a key part of it. Also, where we're seeing deep learning going, particularly in healthcare, because one of the big challenges in healthcare is also predictive learning and predictive outcomes, is the use of advanced neural networks as part of the deep learning process, and algorithms being optimized for that. Real interesting, there's a project by Lawrence Livermore Labs and IBM in trying to take the whole deep learning and broad neural networks into a new stage of deep learning that, in addition to responding to the current healthcare environment, really gets into more predicting future things, trying to be two steps ahead instead of two steps behind and being reactive. And I think that's going to be a very important output as you look at healthcare deep learning and how the deep learning is focused. Uh, some of the challenges you see, though, in deep learning is the lexicon, and particularly in healthcare. The example I love to give in healthcare is in North America, there is a word often used in healthcare called a provider. And what is a provider? I bet you as we talk, even among this panel, we'll come up with multiple different definitions of provider. It's the doctor, it's the facility providing the services, it's the insurance, which is providing the money to pay for the insurance, it's all of those things. And actually, in healthcare here, there's 16 different definitions of the word provider. So what you have to do is you're doing deep learning, particularly with machine learning and natural language processing, you have to build a lexicon. And building the lexicons of how these different words have multiple meanings lets your deep learning function more accurately. Because one of the key assets of deep learning is it will do self-training. And self-training begins to say, I have to have a good grasp of my lexicons I'm using, so that if I'm doing machine learning with the recognizing the natural language processing on that, when I hit the word provider, I have to go backwards and forwards in the text streams, in the free text and things, to understand which of the 16 providers they're talking about. So those are some of the types of issues you see with this. But it's a very exciting field today. It holds a lot of promise, particularly as we look at the complexity of healthcare and how it's continuing to evolve. So, Sharif, thank you.
Thank you, Professor David Smith. Mr. Martley.
Yeah, I love the idea of this concept of deep learning and how it can apply to medicine and a number of other things. I do have some questions about it, and I'll get to those in a second and everything. But one of the things that I love is that it definitely can give you a lot of information that is needed, and it can definitely help the doctors and the nurses and the other healthcare professionals by providing diagnosis, as Rob was just talking about, and a number of other things along those lines. I know that my mom recently was not feeling that well and had to go to the hospital. That was about a month and a half ago. And while she was there, she actually had a moment of coaching one of the nurses, because they were doing something that was, in some cases, be considered a misdiagnosis. It wasn't anything major, but it was more about serving food at a particular time. And if you know anything about medicine and the things along those lines, there are times that you don't want to be having that food ingested along with the other medicines because it can cause some adverse reactions. She recognized that, and she took a moment to have a teaching moment with that particular nurse and everything along those lines. And that's actually where the question that I have comes around and everything, because when we think about AI and technology, a lot of times we think about things like Alexa, and we think about things like what exists in our cars. And like I said, I am not a driver, but I have many friends that are, and I know that they sometimes get frustrated by all of that because they can tell Alexa to do whatever they want it to do, whether that's turning on the lights or doing whatever, and they can definitely get instructions from the car, and sometimes and the kind of AI and things that exist in that, and sometimes it will give them answers, or it will come on at times that frustrates the driver or that frustrates the individual in general. So that's kind of the question that I was going to direct and everything, is how much of this learning is actually going to be personality based, because a lot of times when we think about healthcare and things of that nature, we want good bedside manner and we want good things along those lines. And I don't know how much of the AI and technologically based things will have the kind of personalities that we want. And one of the reasons we love our pets is because they develop personalities, and we love those personalities about them, but just like we love the personalities of our friends and acquaintances. Well, most of the time, we don't always love the personalities, but for most of the time we enjoy what they are, and that's why they're in our friend circles. So I guess my question to Rob and to David is, how much of a personality-based learning has there been, and is that part of the frustration with it in a very much people-oriented field like medicine? Because definitely, if you're doing something in a nursing home or you're doing something at a hospital, you want people that will be able to relate to you. And while I get that a lot of times the diagnosis and that kind of stuff can be wonderful, and we definitely want to get that, and sometimes, as you said, Rob, the doctors and the nurses are not available, and you want to talk to something that may be able to give you the answers that you want at that particular time. But I can imagine that it would also be frustrating if they don't have any semblance of a personality. So that would be my question, is how much of this development is also developing some semblance of a personality, maybe not a total human personality, but at least something that gives you some empathy, because I'm very much about empathy and things along those lines. And that's an important part of medicine. So I don't know if David or Rob or even Marshall is coming up.
Yes.
Have any answers?
Yeah, we give that a shot. So the AIs that you were talking about are basically just front ends to search engines. So they don't really have much personality. That they can have. I've seen some nice work with regard to intonation and anticipating the question, but still they're relatively limited creatures compared to the deep learning computers that we're rolling to market now. When you're talking about natural language computers, that's the ability for a computer to actually understand what it is you're asking.
Right.
And so we're often with using a Siri-like front end, you have to state the phrase that it's looking for so it recognizes the command and does what it needs to do. I was just practicing that with one of my cars yesterday. It's very stilted. I mean, for those that can learn and memorize commands, it works fine. For those that can't, not so much. And it can get kind of frustrating because you're always getting a list of commands, one of which you can repeat and get it going. Some of the newer cars that are using Alexa are a bit better, but we're still not, in terms of the automotive and in-home solutions, we're still not at a point where the computer can provide an interpersonal human-like relationship. Now, the deep learning systems are showing themselves to be pretty promising. Almost a decade ago, I attended in San Francisco the debate between Watson and a professional debater that was held there. And while the judges awarded the debate to the human, which I thought was unusual.
Harish Natarajan.
Yeah.
Yes, he's my friend from University of Cambridge. Yes.
But I thought I thought they were throwing the bone to the human, because the computer, I thought, did a better job of actually talking to the audience. It told jokes. It sounded more personable. It was actually less robotic than the pro. And that's kind of how you do debates. I mean, you're supposed to just provide the facts and move on, while computer was joking up the audience, telling side stories. It was quite a bit more entertaining. It showcased that a computer could emulate emotions, and if you've ever seen or studied how a confidence man works with regard to your empathy, one of the ways a confidence person works is they don't care about you. They make you believe they do, though. So it doesn't require empathy to fool somebody into thinking that you're empathetic as a human. The same is likely true of a computer. With the right algorithms, you get a response that you like, and if the system is learning as it should while it's interacting with you, it's figuring out what works better than other approaches. And when we finally roll this technology on telesales, I'm probably going to yank the phones in my house out of the wall and hide underneath my bed, because it'll be very effective. Certainly as effective as a moderate to superior sales rep. So they've got the potential of creating an empathetic connection. And as I mentioned earlier, they've been in trial in retirement homes for a while, and they seem to work reasonably well there, where you're giving people that don't have a chance to really talk to anybody something to talk to. One final story with regard to empathy, and that's about the Sony Aibo robotic dog, because you mentioned pets. And the initial Aibo robotic dog, which really wasn't all that advanced, came out in the 2000s. Was so popular that it sold out in Japan in less than 10 minutes. But the screwy thing was, when they opened up the rest of the world, it took 2 weeks to sell out of the other half of the volume that they've manufactured for worldwide distribution. And that was because so many people were trying to order the thing, they couldn't keep the computers up for more than a couple seconds, and it took them 2 weeks to build up the capacity to handle the call volume. It just showcases how willing a certain substrate of the population, a large number of people, are to appreciate or at least consider a robotic pet. And of course, if you might recall, a lot of people with Aibos treated them very much like they were real animals, and that was the old stuff 2 decades ago. The new stuff is so much better.
Thank you. Professor David Smith, you want to add any point? Because I think Mark Lee has questioned both Professor David Smith and Mr. Rao.
Well, Mark, I think there's personality in the different types. One of the places where you're seeing this type of deep learning used a lot is in radiology and with image recognition things, which radiology has tended to, over the years, even without the computer involved, to be very mundane in the words they use, without much personality at all. But where you're seeing personalities coming in is particularly as the world begins to transition from being fee for service, where it responds to you when you're hurt, to trying to help keep you well. You're going to see more and more types of patient-facing deep learning and artificial intelligence come into play, where you are going to see more of the personality going there and more of a dialogue. A lot of the AI around deep learning in healthcare so far has been more one way. Give it a set of characteristics, symptoms, what's happening, and it will begin to give you options. And one of the key things in healthcare AI-based is that it typically gives you options versus giving you answers, because of the wide range of variabilities you have in healthcare. You do not necessarily want the computer to prescribe to you. You want it to advise you.
Thank you. We have our another famous entrepreneur, Mr. Marshall. So, Mr. Marshall, what you want to add?
Thank you for having me on this panel, Sharif. Again, I'm honored to be with Rob, David, Mark, and who just dropped off. Anyway, my point, I am familiar with the Japanese bots that were deep learning bots that are used in facilities in Japan because of the aging of the population and the inability to provide the number of staff that's required. So what they did there is they obviously developed, as Rob and David have pointed out to Mark Lee, these bots that actually are kind of like companions they're designed to be companions, not for medical purpose, really. Although I do realize that I think today they're even integrating medical component, medical treatment into that, more like the advisory component, as David talks about, not prescribing anything, but more as a companion to keep these older population people living and healthy and interactive with their environment. Where I would like to take the conversation a little bit is I would like to transition it a little bit, not so much on the speech recognition capability of deep learning and the interaction with humans, but the use of it in medicine has been, I don't know if you folks realize this, but prior to the pandemic, I was involved in, and still am involved through our climate change and climate restoration programs with zoonotic diseases. And of course, COVID-19 is a zoonotic disease. It's transmitted, it's the definition, transmitted between species. Prior to one of the things that we were working on is an animal husbandry feed to be used to reduce the mortality rate of livestock, because you consume livestock if you eat it. They're not pets generally. And so, they're highly regulated in many countries around the world. So if it goes into the human food chain, they want to regulate that. I've been working and still am working with 2 virologists and 2 epidemiologists on this process. And I discovered through the process, one of the epidemiologists is out of Israel, and he's the guy that created a vaccine for MERS, which is a zoonotic disease that's transmitted from camels to humans. But before it ever came to market, it dissipated. However, he's been heavily involved along with the other people that I've been talking to. And there's a fella out in San Jose, California, who's a virologist who began working on the vaccines. Most of the vaccines that have been developed for COVID-19 have deep learning in it. I don't know if you know that. That's why, one of the reasons why people don't understand how the rapidity of the vaccine came to market. Now, there is one component on this. They've been using this type of technology for about 10 years, but it hasn't been implemented in a vaccine until COVID-19 came about. And so what they did is they used deep learning technology to actually advance the development of the vaccines and of the drug specificity components of it, and used it for analysis to understand what the variants are. And by the way, I suspect that we're going to see a very interesting response on the new variant that came out beyond variant D, and that is going to be probably attributable to deep learning technology that they're applying to understand how that affects and how the variants on the different spike proteins mutate. So that's my contribution.
Thank you, Mr. Marshall, for your excellent analysis, Mr. Adam. Mr. Adam, can you unmute, please? Adam, can you unmute?
I don't know if Adam hears us or not. Adam, they're trying to get you to unmute. While they're trying to get Adam to unmute, I did see a question that one of our guests asked and everything, which is, and that's actually a question that I was going to put it in a different context. It was the context of whether deep learning can increase the longevity of people, and that was from Anika Shams. But I can see that on one level because it gives you more time to exercise and to do better things with your diet and other things that they say can help with our longevity. But the other thing that I guess would be the flip side of that, and I guess this is for the rest of the panel, is that we as humans are naturally curious individuals, and we love our curiosity, and to some degree that's kind of what keeps us living longer lives in my mind, because we're always trying to discover new things, learn new things, and that's part of the joy of life, is learning new things on a constant basis. If we are dependent on other individuals or other entities like this deep learning kind of stuff to provide a lot of that knowledge to us, does that kind of limit the curiosity, and therefore at some point might it shorten the lives? Because right now we've been having longer and longer lives because of the amenities that we have, and that's a great thing. And definitely some other developments that have happened that have including medical developments that have caused us to live longer lives than our predecessors. But I'm wondering about one of the fundamental natures of humans, which is that we are naturally curious individuals in one form or fashion or another. But if all of the information is coming to us, I mean, of course, it's being programmed by certain people, but if it's coming to us, does that limit the curiosity, to Anika's point and everything? So I was wondering what folks thought about deep learning and its increase in the longevity, and whether it's going to impact our natural curiosity.
I have a response to that, Mark Lee, and I think it goes directly to the question: will artificial intelligence replace healthcare professionals? That's by Mahdi Hassan Muhammad. That question, and it touches upon the other questions that have been posted on the chat. I think one of the things about deep learning right now, and who knows what's going to evolve, because things evolve all the time. There's new innovations happening. But based on the current knowledge that I have, and maybe Rob can be more specific to this than I am, but my understanding of deep learning is that there's a huge difference between the human brain and computers today that perform deep learning. What the computers bring to the table, or the artificial intelligence brings to the table, is the speed of analysis and ability to do that. What the human mind brings, and that trumps it, in my opinion, is what is called neuroplasticity. Neuroplasticity is the ability for the human mind to do things and take. It's kind of well, my background in psychology says that there is a concept called out of the box thinking, and that is what's known as Gestalt psychology, where you break boundaries. I haven't been able to see, and maybe Rob has, I haven't, or maybe David has. I haven't seen any computer programs that has Gestalt capabilities. In other words, that, like the connection of A equals B, B equals C, therefore A equals C, that computers do. But connecting Q, C, K, and G together is the neuroplasticity of humans. And that's what our brains do, as if you want to think of them as computers. But we have a biological component. The computers do not, and I think that's what they're lacking. And maybe Rob can correct me if I'm wrong, or Dave can, or Adam.
Thank you, Mr. Adam. Can you unmute, please, Mr. Adam? Yes.
I'm really pleased that you picked this kind of topic, especially because of a recent development that's been in the news, and that is the suicide pod out in Switzerland. I don't really know too much about deep learning yet, but I do have some thoughts on health and healthcare in the near or far future. Regarding recent development of the suicide pod in Switzerland, I think that machines like this have the potential to lower the rates of suicide, paradoxically. Why? Because of a, again, rather counterintuitive effect where great comfort is brought to someone who is suffering just by knowing that there is an escape route, a way out, which can be used at any time. I remember someone addressing the subject of suicide and their own mental health struggles. It might have been one of the interviewees on the Software Underbelly YouTube channel, where they said that just knowing that I can simply jump out of that window whenever I wanted to actually brought me comfort, and not just that, but enough comfort to actually want to continue living. Let's paraphrase what they said, which is what the rollout and installation of this machine might do as well, especially if this was a guaranteed quick and painless method, and more suicidal people will feel the comfort of the potential escape route, certainly to a higher degree than what the idea of jumping out of a window brings, being less of a guarantee that it will deliver death as instantly, painlessly and efficiently as one would hope, especially compared to a more streamlined method as per the aforementioned machine. So window, a little reliable, risks pain and slow death by injury and internal bleeding, bit of comfort. Comfort soothes a portion of the suicidal population, thus some lives are saved. But with a suicide pod, which could be very reliable, certain to be quick and painless, brings lots of comfort, and the higher rate of comfort soothes the majority of the suicidal population, thus more lives are saved by this than the aforementioned window. So a similar situation can be found within the psychonaut community, where one of the safety measures for psychonauts who risk bad trips is to have a benzodiazepine on standby. For many trippers, knowing something that something like diazepam is on hand in the case of trips going south is enough to prevent a bad trip altogether, thus not needing to consume any of the diazepam at all in the end. But of course, one of the downsides to the suicide pod development is that nowadays there are many ways to influence a person into doing things under certain circumstances and ways of control that they would otherwise never do without the influence of such forces. And one dramatic example of this is the drug scopolamine. And scopolamine is a delirium, I believe, unless I'm mistaken. I think it's a class of drug called the deliriums, which also includes some of nature's own plants, such as datura and Jimson weed. I was very surprised to see scopolamine being used in medicine back when I used to work in a pharmacy, which was used for treating motion sickness, I think it was, car sickness, in small doses. And of course, in mega doses, it's very dangerous and being used in places like South America and other impoverished places where gangs blow scopolamine into a victim's face and they become highly susceptible to suggestion, even to the point where they do this to tourists and they're made to go to a cash machine, give gangs all their cash, and then they step out of it remembering anything. But furthermore, to preventing coercion, blackmail, or being influenced against one's will into stepping into these kinds of pods, it could be a committee of independent adjudicators who, in a position of neutrality and responsibility, could determine whether or not someone is being made to step into a suicide pod against their will, or whether or not they are under the influence of intoxication. Or to tie this back into the subject of deep learning, I'm sure an artificial intelligence might be able to tell, just from scanning or even looking at a person and reading BPM, perspiration, neural activity, microexpressions, whether or not someone is under duress. So hopefully developments like that, combined with hopefully less punitive measures regarding psychedelic substances, eventually, hopefully these factors happening in tandem will lead human society to a situation where a multi-pronged approach to therapeutics will be more effective for mental and physical health problems than what we have now. Thank you, Sharif.
Thank you. Thank you, Professor Rob, actually, for engaging with this deep learning in healthcare. I believe there are a lot of challenges. So if you share different kind of challenges, maybe our youth community, they can find out something and they can take these challenges and solve something.
Well, I thought I might start off by answering Marshall's question. He's been waiting patiently for the answer. And there were two questions. That we had the question with regard to whether or not these machines could increase the longevity of people. And so let me deal with that one first, because I've been thinking about it a little bit longer. And the answer is yes, it's being used that way now. We're using machines to both look at the factors of aging and determine which things we can affect and change. And deep learning computers can handle massive amounts of data and can look across the entire population of the planet. With federated data, one of the problems we've got right now with deep learning machines is the fact that medical data is highly segmented. But one of the things that the research into COVID did is it opened up a lot of these data sets. And now we've implemented federated data programs, which would allow you to keep patient's information anonymous, but still look at the underlying trends and make decisions from those trends. And that allows us to take a look at things like diet, medications, and gene, what's the word I'm looking for? Using CRISPR to modify genes and your DNA to address your long life problems. And then, of course, the other angle we've taken is to digitize our personalities, to actually take, and there are a number of efforts focused on this. A Lifeboat Foundation covers a lot of them. And then digitize us, and then make us virtually immortal. Granted, it's not us, but it's a close enough simulation that it could fool others that it is us. Marshall also asked about whether or not we could emulate the intuitive nature of people. And once again, the deep learning model is showcasing some efficacy in that regard. And the ability to infer conclusions and hopefully do so better than we do, because one of the problems people have when we're inferring a conclusion that's based on a incomplete collection of data, which is what we can do, at least right now, better than machines, is we often get it wrong, and we introduce a lot of bias into the process, which is problematic. And we have that same risk with regard to these computers that are coming up, and that's why, for instance, IBM Labs just recently published program that looks at causal analysis and the development of AI decision making, and that's to get rid of all the biased methods of making determinations that we use as humans, and a lot of computers would use as well. We remember some of the initial implementations of AI with regard to image analysis had the computers connecting certain races to animals in a very unflattering fashion, and that's one of the reasons why IBM actually left the segment, because so much of it was bad training sets that were resulting in very racist outcomes. So it just points to the promise of the deep learning computer and our ever more capable AIs, but it also points to the problem of when you have incomplete data sets, or if you've got developers that are not properly taking out the biased elements in their own programming and in those data sets, and creating computers that make bad decisions at machine speeds, which would be problematic. Now, Sharif, you had a question you wanted me to address. What was that again? I'm sorry.
Like, what are the challenges like deep learning has to engage with this healthcare system?
Well, the big one is data access. I mentioned that earlier. The various labs and healthcare providers have been reluctant to let their research data out, even before we had laws that heavily protected patient data. The way around that is federated data, at least with regard to patient anonymity, but it doesn't address the issue that these healthcare providers and research institutions want to monetize their work, and they don't want other institutions to steal it and come up with that new drug or treatment or whatever before them or along with them. They want to capture the majority of the money that comes with that development, and that's proving to be a very difficult problem to overcome, because it makes it very hard for research organizations and institutions to share the data that we need them to share to make broad determinations on a subject like increasing the life of humans. Because to do that kind of a broad project, we need access to as much data as we can to make sure that when we're making modifications to people, we're not creating the zombie apocalypse or something. So that's a stretch. The unintended consequences and consequential damages can be extreme if your data set is compromised and you can't look at as many people as possible, so you can see what the unintended side effects might be and mitigate them early on.
Speaking of unintended side effects, I had two quick questions for everybody. I know that they say, and I brought this up on the panel several times, that we as humans use roughly 10, maybe 15% of our brain power and things of that nature.
Let's stop. That's not a true statement. That came out of the movie Lucy when we last saw it, and it spread rather broadly. But no, we're pretty much using all our brain. That wasn't science. That was science fiction. It was fun, but don't equate the two.
Okay, well, I'm glad to know that we're using more of our brain power, because I was wondering if we're not using all of it, and I'm glad that you corrected me on that, because I've heard that from even scientists stating that fact as well, that they wish that we use more of it. So I'm glad that you corrected me on that. But if that is the case, that we are using it, is it run the risk of us not using as much if we depend so much on the deep learning and computer things along those lines? And the second part of that question I was going to ask is that along those same lines, and I just lost my train of thought. Speaking of trains of thought, so I'll get back to that in a second if somebody wants to take that.
Well, I'll answer your first question for you. There is a risk whenever you use a prosthetic that you won't use whatever it is you naturally receive. So if we put exoskeletons on people, unless we've built in resistance, there's a pretty good chance our muscles would atrophy. Same thing with the brain. If you're sitting back in a Wall-E-like world and things are being provided for you by AIs, and all you're doing is consuming media and vegging out, there's a pretty good chance our brains will evolve over time or devolve over time. As a result, we have to exercise whatever it is we're going to use, and if we don't, that becomes a problem. And clearly, some of the outcomes of massive AI and robotics are that they're doing everything and we don't really have anything else to do. And I think under those scenarios, the race ends. Musk has highlighted that. Gates has highlighted that outcome as well as a concern. A bigger concern, of course, that would happen much sooner is if we weaponize the AIs and lose control over the weapons. That's more near term. We are a long way away from being surrounded by robots that are doing everything we want them to do. But we're right now in the midst of developing artificially intelligent drones, land-based robotics. You want to see some scary stuff? Look on YouTube at the stuff that Russia's developing. It's frightening because they have no restrictions. New Zealand, I think, just popped up with a recommendation that we pass laws preventing the development of these weapons. But when it comes to wars, I don't think those laws are going to have much effect. Particularly not in the countries that don't adhere to whatever treaties result. We're going to need a better way. But the end risk that you're talking about is a real one. We do have to be careful that we don't so augment humans that we stop being human and we devolve into something lesser than what we are. So it's a valid concern, and there are people working on it. Like anything, though, as we develop technology, we often bring the technology out first, let it do damage, and then figure out how to fix it. We are really lousy as a race with regard to anticipating problems and mitigating them before they become critical. Look at climate change, for instance. So a topic we brought up before. So it's a valid concern.
I remember the second question.
Mr. Markley, sorry, because we have to focus on audience. World Talent Economy Forum, not only just this dialogue. We have a plan, we have a strategy, we have to help people. So people need to learn from our audience, speakers. They are very valuable. So we take your questions. Professor David Smith, Anika Shams, is deep learning can be a reason that increase the longevity of people? Even it's very basic question, but I think this is the demand from our audience.
She always asks great questions. The way to increase longevity is a combination of things. It's being able to address the current situations you have, the current problems, which deep learning in healthcare will be able to do that. Part of it's to begin to improve what's going around you. So you have things like regenerative medicine, where you can begin to actually regrow parts that might be failing and other things like that. That's progressing. And actually deep learning is driving a lot of that science as well. So you begin to see that. As Rob mentioned, you have the environmental and ecosystem challenges that can affect longevity, and deep learning's involved with there as well. So the short answer to her question is yes. The longer answer, though, is that longevity is a wide range of things. It can be from very much episodic. You're in a car accident. You have things like that, to genetics. And the whole range of genetics healthcare also involves deep learning as well. But all of those contribute to longevity. And yes, it begins to really be able to help and expand that.
Thank you, Professor. Mr. Markley, Noor Fazrin, she want to know, can AI diagnose better than doctors?
Well, that's actually one to come back to the question that I was getting ready to come back to and everything. I think that AI, if it's given the correct information, can do probably a better job. And one of the questions that I was going to bring into the conversation was there is entire parts of the population that we as humans are not doing a good job of diagnosing. And one of those is mental health. And I've actually just watching a documentary recently, and it comes back to something that Adam was talking about, where there are lots of people walking around our society that are either undiagnosed or misdiagnosed or are able to get the treatment that they want. And this is actually one of the crises that is going on, particularly here in the West, but I would argue the rest of the world as well. So I'm thinking that that could be something that AI might be able to get to better than even the human population. But I'd love to know what Rob and David think about that, because I do know that the whole mental health part of our healthcare system, and I agree that the healthcare system as a whole needs some work, but I would argue that the mental health system needs even more drastic work. So I was wondering y'all's thoughts on that, because I'm thinking that AI might be able to do a better job than that. And Adam kind of alluded to it when he was talking about people that are suicidal. So I'd love to hear folks' thoughts about the mental health aspect of AI in the sense of being able to diagnose that aspect of health.
Thank you. Mr. Marshall, there is one of the problem come from developing world. You know, the developing nation, they do not have, I want to say, healthcare insurance and this kind of policy. That's why healthcare systems and it's very expensive for developing worlds, even India, Bangladesh, many of the countries, even Pakistan, I believe, that this kind of a problem they have. So, Alea, her question is that, yes, is it true that AI can help the medical industry a lot? But do you think that doctors are more dependent on diagnosis? Yes, now any hospitals you go to in the developing world, they give you a lot of diagnosis, and some point it's very expensive for the people. Definitely, not some point. It's definitely very expensive for the peoples. What do you think? And if you share some of the view from USA context and give us some good example from USA, Mr. Marshall.
Well, as a response to that question, I believe that that it's expensive around the world. The United States is trying to move towards a system that is based on healthcare for everybody, but it's not there at all. You people in the United States get their healthcare normally through their employment. Whereas if you're in the UK, you get it through a program that is based on the government, a government-based program. And the same thing in countries like Israel. Throughout the Middle East, it's in other parts of the developing world, and the healthcare is privatized in a way, but it's partially government. I think the issue is really that one has to come up with a construct to pay for it. But can artificial intelligence and deep learning help in that process? I'm not so sure. I don't think I'm the expert to answer that question. But I do think that with regard to Mark Lee's question about mental health, I can talk about that because one of my backgrounds is psychology and clinical psychology, as a matter of fact. I think that there's a misperception by many people in many countries around the world about mental health. It's considered culturally a taboo subject, and that has to do with less with artificial intelligence and deep learning than it has to do with cultural affectations. So in the United States, there's a segment of the population that gets therapy and gets good therapy from treatment. But again, who pays for it? So it all ties together in one aspect or another, that in order to get the proper type of healthcare, whether it's mental or physical, and to be able to implement deep learning for either drug development or other medical processes, one needs funds to do that. And I think a better mechanism is out there. That's one of the things that hopefully we will be discussing in a future panel. I have some thoughts on that we will be contributing, and on how to get the types of money for climate change, this subject matter, and other things. I think we're going towards that, and I think we're evolving in that framework of how to pay for advancement in humanity, as other than, I mean, it seems to be plenty of money in as was delineated on this this panel about making using deep learning for drones to kill people. I mean, there's plenty of money for that, but there doesn't seem to be plenty of money for the health care of people. So to me, it's a cultural and attitudinal adjustment that needs to be made. I think people have to it's just like mental health. People look down on mental health as a taboo subject. It shouldn't be. Mental health is similar to physical health. Some of it is physical. Some of it is your neurons and your chemistry in your brain. Some of it isn't. Some of it is acquired through trauma. Trauma is a big issue in all these aspects. And if you want to really address Mark Lee's question, you need to go to the heart of the issue, which is trauma. And trauma is caused, I mean, the fact that we have wars are caused by people who I believe had poor childhoods. Look at Stalin. What kind of childhood did he have, or Hitler or people like that? So, and I think if you look at modern day leaders that are threatening other societies, I think they're traumatized people. They don't talk about it, but that's what we're dealing with. Now, trauma and deep learning, there is a connection, but not as advanced as, let's say, in drug development and getting vaccines out there. I think deep learning and medicine go together hand in hand, but I think the expectation is that I think we have a higher expectation than what is reality. Although Rob did point out very appropriately that there are some good things that are happening and developing. And as the adoption of these innovations come into the marketplace, we're going to see a transition for good and for ill on how people deal with this stuff. So that's my 2 cents in it.
Thank you. This is really great discussions, and I believe our audience, especially, they learn a lot. And I request all of our audience, please share our content with your government, with your corporation, with your academia. And I want to share more good news. I think Bill Gates, he's working on the problem of toilet issues. This is very interesting. I think this last day of our summit, we discuss on toilet foundations. And yes, World Talent Economy Forum collaborating with Jacksim. He's one of the famous entrepreneurs from Singapore. He has the biggest foundation for the toilet, and especially developing nations. It's very, very important that they have to utilize the toilet. This is another challenges we are discussing about healthcare issues, especially dependent on these toilet facilities. I think it will be another interesting journey from World Talent Economy Forum. As much as possible, we are trying to figure out the problem of real world. Example like Rwanda, example like Malaysia, example like India. And with this dialogue, we are trying to find out the summary, and strategically, we helping the nations of different countries. So we need more of the support from the global communities. We need more team, those who have time. I know all of you are very busy, but if you want to support World Talent Economy Forum initiative, you can. Yes, we start our journey. You can check our School of Talent Economy. We start our journey with 600 people in Rwanda. Same time, we will add another 600 from Asia. So this year, we will just focus on 1,200 students, but in between 5 years, we will reach 1 million people. That is our target. We need fruitful dialogue. We need fruitful solutions, and we need people who can help us. Maybe in the future, we can reach billions of people, and your solution will be helpful for billions of people. It's possible. So let's focus on developing nations. Yes, I always believe developing nations has a lot of problems. They need a lot of solution, and they need great problem solver like Professor Rob, Professor David Smith, Mark Lee, and Mr. Marshall. Thank you everyone for joining today's session. I directly want to go for the concluding remarks. I want to start from Professor Rob. Professor Rob.
Well, deep learning provides a tremendous tool for the medical industry. Everything from assisting with diagnosis. I mean, back when IBM Watson was first demonstrated on Jeopardy, they had an effort that was working with doctors, and I still remember the story. The doctor I interviewed at the time, he said that he had a patient that had been very difficult to diagnose. She'd been gone 5 years with excruciating pain, and through different specialists, and with no help, and she was very depressed, arguably suicidal. It was a level of pain she couldn't survive. And as a young doctor, he decided to pick up her case and see what he could do with it. And after 2 years of heavy research, he was able to figure out what it was she had, prescribe a remedy, and get her cured. I was kind of surprised at hearing that. She lasted the 2 years, but that's how long it took. When they first trained Watson, Watson was able to get to that same answer in 15 minutes. Now it listed a number of potential remedies. The one that the doctor had discovered, I think, was number 7. So it would have still required looking at those other potential remedies and running through the process, but it would have taken far less with a machine that is decades older than we currently are using to come to a conclusion that was accurate and solved a problem. And it would still been a fraction of the time that she went through before, because if he hadn't picked up her case, she probably would have died with that illness, either by her own hand or naturally. These systems can do tremendous work. And as Marshall pointed out, they were instrumental not only in developing the antivirals, but in developing the medications that could be used to mitigate the symptoms. IBM's own computers were heavily used on the latter, as was a number of the largest supercomputers in the world powered by AMD technology. And I got a chance to look at most of those. So a fascinating time. The part for me that's the most interesting is the natural language processing, because that's where the patient can have a conversation with the computer. And certainly during a time when you're trying to keep medical professionals away from patients, so the medical professionals don't get infected, being able to have a computer that could have the interaction with the patient could keep those people far safer by keeping them away from the patients that are sick. So it's going to make a huge change. I expect the major portion of the change, though, won't be until after this decade. We have a lot of learning to go. One of the questioners asked about doctors and diagnosis. Not only do we have to develop computers to do this, but doctors have to trust them and be willing to give up a certain amount of control in order to take the recommendations from the computers so they don't feel challenged by the computer's capabilities. That's going to be a difficult path for us to go through, as I expect a lot of doctors will resist for a long time using this tool, some for good reason. So this is a process where the major impacts will likely be felt, not this decade, but next decade. And by that time, we'll see a revolution.
Thank you. Professor David Smith, what's your concluding remarks for today?
Great topic. It's one that is pushing the boundaries. I agree with Rob that for the general population, the big impact from this is going to be about 8 to 10 years away. Early in the next decade, where we'll see the things really come into play. But we're already beginning to see some other early elements of it today. Even in hospitals, you're increasingly seeing defibrillators where the doctor or the nurse doesn't push the button to give you the shot. The machines take over, they diagnose it, they look at how much of a voltage to use, what timing and stuff, and they'll deliver it to you automatically. So you're seeing places where AI, which has been based on deep learning to build the models and the learning, already beginning to be deployed. You're seeing it in operating rooms and other places like that. So it's there, but these are more machine-centric AI deep learning than interacting with the patients one-on-one. One of the real interesting challenges, though, in healthcare that deep learning is playing into is that in healthcare, many of the records are free text, unstructured data. And they're not structured data, which really lends itself very well to machine learning and deep learning. So you're seeing that type of unstructured data is part of what we need to work through, as we've all talked about before you can go in and roll this out widely to the masses. Is unstructured data is a much harder problem than dealing with structured data in machine learning and deep learning. There is a place I was involved with some doctors in my last company before this one, where we were a healthcare company, and we were developing a platform, an open innovation platform that's based on the new standard that's going to help solve one of the problems that Rob introduced earlier. There's a new standard in the United States called Fast Healthcare Interoperable Resources, or FHIR. And it's a data model that's designed to make this data interoperable between electric healthcare record systems and others as you go forward. And it's kind of interesting. In this whole deep learning area, and talking to some doctors about before, they were saying their big problem is that the data comes from multiple clinics, multiple labs, multiple hospitals, and they all label their data different ways. And that the machine learning algorithms and the deep learning algorithms have not progressed to a place where it can tag and normalize that data. And see, one of the things you really need in deep learning is to be able to normalize that data. And when you're looking for the presence of multiple diseases in a patient, there's not enough data to look at every combination of those diseases so that you can produce the outcome. Deep learning is an approach there, but disease is a complicated, multiple disease criteria usually. I can tell you, I went to the doctor this week because of some lingering pain from when I was rear-ended in my car. And it's really interesting. The doctor diagnosed 3 different things that were causing me the pain from that accident, with 5 different types of medicine to deal with the 3 pains. So again, it's these more combination of things in healthcare that we're deep learning, being able to advise the doctor, will be where the big breakthroughs are. One of your questions was, will deep learning replace the doctor? In 90% of the time, no. But in some places you're seeing it. One of the projects I worked on in the military is a robotics AI trauma pod that gets distributed in the battlefield. And that very advanced trauma mitigation, including surgery and things, can be done autonomously in this pod in a battlefield situation to save lives and to reduce the impact. Now, I think you are going to see this type of deep learning and AI and robotics and sensor integration replace doctors in instances like that until they can be stabilized and safely evacuated. But as a whole, it's going to come back and I think work well. So Sharif, great topic. It's one where we're in the midst of the S curve of its learning and of its deployment. So great timing for you, because it's at the point where many people can still contribute to it.
Thank you, Professor David Smith, for your continuous support for World Talent Economy Forum. Mr. Marshall.
Yeah, Sharif, I think that David and Rob have, if you combine their pieces of information, you have a very informative panel and directly to the topic of deep learning in medicine. What I think I can contribute to this is that I'm connecting the dots between deep learning, medicine, and climate change. Climate change affects our health directly. The more GHG emissions we emit, the more health issues we have around the world. And I also want to connect it not just to the industrial world, but also to the developing world. Developing world has a lot of issues. If you take a look at a country like India, it's a huge population, billions of people, not hundreds of millions, but billion plus. And one of the things that's going on is that 40% of that population is off the grid. They don't have electricity. What are they doing with their time? Women and children, instead of going to school and being productive in the economy, are spending their time going out and gathering wood to burn it, which then causes pollution, which then causes lung infections and all sorts of other medical practices. And there are no computers there, no deep learning to connect, or a modification such as David brought up, like a battlefield trauma unit that they could deploy there. I think what needs to happen in order to bring that part of the world up to speed, even to the point where, even though the industrial world is still behind, as Rob and David talked about, it's about 10 years out till we see some really strong benefits. But we are seeing benefits, as both Rob and David did point out. But we're in the early stage of the S curve, where the developing world has to come to the table, or where we have to come to the table on behalf of the developing world. That's probably better focus, is to be able to connect the dots between the healthcare issues, improving the quality of life of people, and a simple, basic, fundamental issue. It's my belief that deep learning can contribute to that, not just through medicine and applications as drug interventions, as we talked about before, and as what Rob talked about in terms of medical applications, but also in environmental applications, because environment is directly related to our health. So I'll connect those dots, and again, it's a pleasure being on your panel, Sharif, and Rob and David. It's an honor to be with you guys on the same panel. Thanks.
Thank you everyone for joining today's sessions. Bye-bye and take care.
Cheers.